You've almost certainly heard of GPT-4 and some of the really impressive stuff it can do. And this video is about just that, seeing what we can do with GPT-4 as we push it farther and farther, and then eventually where it inevitably fails. Speeding through these whopping 155 pages of practical GPT-4 experiments will cover many of the things GPT-4 can do very well, from coding to drawing to tool usage. Then on the opposite end of that spectrum, where the limits of its current abilities lie. And of course, we're going to have to talk about the elephant in the room, this paper's main title, Sparks of Artificial Intelligence, or AGI. A word which up until just about several years ago was basically taboo in the field, let alone in a paper written by a team of well-respected researchers from Microsoft. So is the title just a ploy to get some more clicks by capitalizing on hype, or is it finally time that saying AGI in a paper is perfectly normal and okay? We'll get there. But first, with 155 pages of experiments ahead of us, let's start with a speed round, showcasing some of what GPT-4 can do and how it compares to an earlier version of ChatGPT. GPT-4 can draw images using JavaScript, like this lovely unicorn, whereas ChatGPT can make this. It can also pass a mock technical interview for Amazon with a perfect score. As someone who has done this myself, I can say it's maybe not the hardest of technical interviews, but nevertheless, very impressive. GPT-4 can tell you how to stack a book, 9 eggs, a laptop, a bottle, and a nail without any of them falling over, whereas ChatGPT recommends placing all 9 eggs on top of the single nail. Not quite sure that's the best idea. GPT-4, like previous models, does still hallucinate and makes up false information, like the location of McDonald's at the SeaTac airport. Absolutely despicable behavior. Beyond just unicorns, it can also come up with some pretty cursed images of 2D and 3D scenes. Yeah, the prompt for this was, a frog hops into a bank and asks the teller, "Do you have any free lily pads?" The teller responds, "No, but we do offer low interest loans on pond upgrades." You know, it just makes me wonder how absolutely toasted the authors were when they thought of this and were like, this is a great idea for a Microsoft paper. You know, all I have to say, absolutely great work. This is what peak machine learning looks like. Back to what GPT-4 can actually do well though, well, it can generate these simple designs, which with the help of something like Stable Diffusion can be turned into quite a nice sketch. Using this text format you can see here, GPT-4 can even generate sheet music, although the results are somewhat limited and simplistic. GPT-4 significantly outperforms previous models when it comes to coding challenges. For example, here on the human eval, it gets an 82%, and again, higher in every category on LeetCode problems. It can even implement complex functions like this custom machine learning optimizer. Here, GPT-4 perfectly codes up the momentum here, whereas ChatGPT makes a fatal mistake in this implementation. It can also develop simple games like this one made in HTML and JavaScript. And in perhaps one of my favorite examples, beyond just writing code, here GPT-4 reverse engineers a binary to crack a password by using tools like GBD to step through machine code, and even Python to write a password cracker. Heck, maybe even better is the fact that it can write incredibly complex functions like this in LaTeX, because I can guarantee you this is going to save me hours of anguish. On the same problem, ChatGPT's response, well, it doesn't even compile. That is a lot of stuff GPT-4 can do, and I already skipped over a lot just to get to this point. But now we get to where things get a bit harder. And here we'll see where GPT-4 might start revealing some of its flaws. Speaking of which, if you want to be prepared to catch flaws in your own experiments, you should check out today's video sponsor, ClearML. ClearML offers an end-to-end platform for ML ops, where you can do everything from tracking experiments to automating an entire machine learning pipeline through to deployment. Here's the code for one of my current projects, and with just an extra several lines of code, I can integrate it with ClearML. And with that, we can now pull up a dashboard and see the progress of my experiment as it runs. Here, I'm just logging the loss because I wanted to get this done in a few seconds, but there is a lot more you can do with this. But really, this is just the tip of the iceberg. You can also create entire pipelines that pull in different versions of your datasets, run hyperparameter sweeps, automatically set up new environments, and because of that last point, ClearML has no problem with scaling. As I run many experiments in my own research, I personally love some of the features that help me with that. For example, I love how ClearML not only tracks code version, but also uncommitted Git changes, which is very nice. And also how through the dashboard, I can inject configs into my experiments, which means I don't have to constantly be modifying my code to run a bunch of new experiments. If that sounds like something you're interested in, you can try out their product for free by following the link in the description below. Getting back to GPT-4 and that math I mentioned, it can do math at a decent level. like in this instance, where it solves this word problem that requires 1, the ability to create its own equation, and then 2, the ability to algebraically solve it. But from here, the authors continue to prod. First, they ask the model to reformulate the original question, and it can do that just fine. Next, they ask it to prove something about the previous question. Here, GPT-4 chooses to use induction as a method of proof, which is actually the correct way of proving this, but the proof it ends up giving is actually incorrect. When asked if it sees the issue, it says it does, but then when it tries to explain the issue, it ends up messing up its own logic even further. And through several attempts of this process, GPT-4 almost always led itself to a logical dead end. To dig further, the authors try this same thing again, or at least something similar, but this time with a different equation. The model initially has a bit of trouble, but with a bit of help from the human, it eventually gets the right answer. But again, we see a same pattern, which is when the authors continue to prod and ask more questions, eventually, and pretty quickly, GPT-4 runs into some invalid logic, and then when asked to correct it, it just gets worse, and it just continues to fail and trip over itself. The authors recognized that this was a commonly occurring pattern where GPT-4 would often dig itself into a hole with bad logical reasoning and having an inability to go back and fix some of its prior mistakes. These are certainly some interesting results, but how do we take these results and turn them into some sort of assessment of GPT-4's capabilities? Well, the authors do so by breaking mathematical skills down into 3 categories. The first is creative reasoning, which they define as the ability to intuit the path to a solution even before you know exactly how to solve the problem. GPT-4, for example, demonstrated creative reasoning when it correctly guessed that one of the first problems could be solved by induction. In this regard, the authors think that GPT-4 is around the level of a good high school student or potentially even higher. The next category is technical proficiency, which has to do with the ability to perform routine calculations and apply formulas. Here, the model knows a lot of equations, which certainly helps, but that doesn't stop it from frequently making trivial arithmetic mistakes. We can see, for example, that on the math dataset, a whopping 68% of its incorrect answers are simply due to these arithmetic mistakes, which is certainly not great when humans would often view this as one of the simplest parts. And finally, we have critical reasoning, which is the ability to, reason about an argument, to be able to break it down into subcomponents and see how they all interrelate, and this is where GPT-4 sees its most significant shortcomings. As we previously saw, it frequently digs itself into logical holes, showing that there is much to be desired in its ability to individually reason through steps and correct prior mistakes. And as the authors point out, this is likely not just a flaw with GPT-4, but inherent to all large language models that are trained in this way, because LLMs are mainly trained to do sequential next token prediction. They aren't really incentivized to have an inner monologue that looks back to correct prior mistakes. Even if it was that way, the linear nature of the outputs means it can't go back and overwrite previously wrong answers. These are problems with GPT-4 that certainly can be solved, and scale in model and data I'm sure would help, but if we want to make useful strides, perhaps moving beyond the linear nature of this next token prediction might be useful. But now let's move beyond math and into the domain of interacting with the world. One of the most exciting new trends for practical applications has been GPT-4's ability to interact with external tools. This can be helpful because, 1, tools make up for deficits in GPT-4's own capabilities. For example, here GPT-4 is unable to answer questions about recent knowledge, like the current president of the US. It fails to calculate the square root of this pretty simple equation right here, and by equation I just mean 2 numbers multiplied together, and it cannot even give the 13th letter of the word supralapsarian. And tools can also be helpful by 2, allowing this model to interact with its external environment. And with tools, GPT-4 has no problem solving any of these, finding the current US president, calculating square roots, or even finding, yes, the 13th letter of the word supralapsarian. When you equip GPT-4 with the ability to do Google searches or use a calculator, the amount of things it's able to achieve suddenly skyrockets. Or you can give it something much more complicated, like access to a Kali Linux terminal, which is a distribution designed for hacking, to have it perform penetration testing and hack into other devices on the network. Or back to something a bit more tame is you could potentially save a lot of time by giving it access to your email, functions it can use in your email and calendar, and have it set up dinner meetings for you with your fellow colleagues without ever having to write a single email yourself, including even making a reservation at the restaurant. Tool usage like this is awesome, and it is all the better than ChatGPT that generally ignored tools even when given. But as the authors point out, there are still several limitations here. For one, GPT-4 still requires a prompt that specifies if it's allowed to use these external tools. So if, for example, you need lots of text to talk about how to use these tools or give examples, well, you're already using up lots of that precious context space. Second is that GPT-4 does not always know how to reason about when it should be using certain tools and for what. In the example given here, GPT-4 uses a Google search to Google the capital of France, even though that is something it should and almost certainly knows even without Googling it. And the third problem is that GPT-4 still does fail to use some tools, notably tools that are somewhat unusual. We can see this in an example when it's given these two functions, reverse get character and reverse concat. When GPT-4 actually goes to use these functions, it uses them as if they are the normal functions instead of the reverse versions, causing it to get the initial answers wrong. So far, we've gone through a lot of interesting parts of this paper, and I want to start pulling all of it together and making some conclusions. But believe it or not, we still have about 50 pages left in the main paper. So first, let's do one more speed round of experiments and findings. And as we get into it, consider subscribing to the channel if you've been enjoying this. Condensing 100 or 155 pages of information into a meager video is a lot of work, so I really do appreciate all the support. Starting with GPT-4's ability to generate mental maps, when allowed to step through a text environment consistent of many different rooms, one room at a time, GPT-4 is able to piece together a spatial map of where everything is located, showing that it has some ability to do this form of spatial reasoning. It even possesses some level, or rather a high level, of theory of mind, which is the ability to attribute mental states to other people than yourself, essentially knowing that other people are actually humans just like you and not some weird robots or just part of the environment. For example, if Alice puts a photo.png file inside of the photos folder and then Bob moves it to the temp folder, GPT-4 knows that Alice is probably still going to look in the original photos file because it has some ability to look at the situation from Alice's perspective. Or in instances like this where two people are talking and one person makes a sad face, GPT-4 is able to infer some reasons why that person might be sad. Or, oh boy, getting into some spicy territory here, it can even tell you how well discussing vaccines at a family Thanksgiving dinner is likely to go over based on the political affiliations in the family and their various positions. And I'm pretty sure it can do this better than lots of humans can. GPT-4 is sometimes able to give explanations for why it gives certain answers. For example, here, when it answers in Portuguese, it gives an explanation for why it picked the male noun for a doctor when you could also use the female version. But sometimes when testing if it is actually consistent with its explanations over multiple new sessions, well, it is not always consistent. Sometimes it is, sometimes it's not. Though to be fair, I'm not sure how many humans are also always consistent with their own explanations. And now, taking into account everything we've seen so far, let's talk about limitations. And one of the main ones that the authors come back to is GPT-4's inability to plan ahead, or step-by-step work through problems as part of a working memory. A quick counter is that GPT-4 can actually plan out things on a sketchpad. All you have to do is ask it to think step-by-step in its prompt. For example, in this problem, when it is asked to figure out how many primes are between 150 and 250, the zero-shot answer is wrong. There are not 13 primes, or at least there's more than that. However, if this prompt is adjusted to ask it to first list the prime numbers and then output the size of the list, well, it can do that just fine, because once it outputs them, then it's very easy to count those up and say we have 18 primes. The issue is that this type of prompting isn't always sufficient. As the authors note here, one might hope to solve the problem of models' very small working memory for some types of tasks and its lack of basic step skipping by always adding the correct instructions to the prompt and allowing it to use extra tokens as its working memory, which is what we just did in the previous example. However, it seems that the autoregressive nature of the model, which forces it to solve problems in a sequential fashion, sometimes poses a more profound difficulty that cannot be remedied simply by instructing the model to find a step-by-step solution. And of course, this claim does not come out of thin air, but is backed up by a few examples we can go over. In this first example we'll look at, the goal is to modify this equation such that the right-hand side ends up, or rather both sides, end up equaling 99. The catch is that on this left-hand side equation, only one of these integers can be modified. we can see that the model actually starts out with the right line of logic, saying that since 99 minus 72 equals 27, it must be that we have to increase one of these digits on the left such that the entire value increases by 27. But then it very quickly makes a mistake when it says, for example, if we replace 9 with 27, we can multiply it by 1, but it is forgetting that you can only change one number. The author's pointing this out as an example of it being hard for the model to even plan one step ahead. When it proposes replacing 9 with 27, it's already forgotten or has not planned ahead to the part where it can't change the 4. But once it has that in text, it can't change its answer anymore. It's not able to go back. And because of that, it follows with this incorrect logic and ends up giving an incorrect solution. Or in the case of text, we can compare two different examples. In both of these cases, you'll see the goal is to get GPT-4 to produce some sort of poem with different local and global constraints on what it can produce. In this first example, the global constraint is that the first letters of each sentence, or rather each line, must spell I am Da Vinci 3. And the local constraint is that this poem must end with some sort of dark plot twist. Because both of these can be done greedily, or in other words, without any sort of planning ahead, we would expect it to be able to do this just fine. And if you look over the poem, we can see that it does. And there is a dark twist at the end of the poem. Go ahead and read it if you want. But just beware that it does involve devouring babies. The things GPT-4 comes up with. But now let's try imposing a different constraint. In the new constraint, the poem must start and end with the same line, but the final line must be the reverse of the first line. This requires quite a bit of planning ahead because you can't really start the poem until you already have something that can be reversed. At least that's how you have to do it if you want something that makes sense. And because this is not something you can do greedily but must be planned, we would expect that GPT-4 would do worse here. And indeed, it certainly does. We can look at its first attempt where it starts with, I heard his voice across the crowd, and it does successfully reverse that. Crowd, the across voice, his heard I, but not very poetic now, is it? And as we see it continue to try again and again and again and again, it fails basically every time, even though the human is trying to help it out. We can look over some more of these. You are the sun that brightens my day, day my brightens that sun that you are. Maybe a little bit closer, but really no. And we can continue, and it's only when the human helps it make very, very short things that it kind of works. We need both to survive. Survive to both we need. Both need we. Maybe it doesn't even work. Maybe it's just the fact that there's less words and less to mess up that it sounds a bit better. These issues really do make it seem like one of the biggest issues with GPT-4 is its lack of ability to plan, no working memory, ability to backtrack, and reasoning abilities. All of which are a consequence of the reliance on a greedy next token generation training regime. The authors make what I think is a pretty apt analogy to Kahneman's model of fast and slow thinking. These are roughly described by saying that fast thinking is a mode of thinking that is automatic, intuitive, and effortless, but also prone to errors and biases. Slow thinking is a mode of thinking that is controlled, rational, and effortful, but also more accurate and reliable. The idea here being that GPT-4 excels at this form of fast thinking, but really lacks when it comes to the ability to think slowly. And while this limitation may be the focus of this paper, there are many other issues that also remain. Here, a list of a number of these are given. There is confidence calibration, long-term memory, continual learning, personalization, planning in conceptual leaps, transparency, interpretability and consistency, cognitive fallacies and irrationality, and challenges with sensitivity to inputs. And of course, even with 155 pages of experiments, there was not enough time to cover all of these in just this. And what about this whole AGI thing I talked about in the beginning? Let's talk about what they mean by that in this paper. The definition they use for intelligence comes from psychology, and it is a very general mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. And what they mention is that the focus of this paper is trying to evaluate GPT-4 around these different properties, which I would say they do for the most part, except for maybe learning quickly and learning from experience. And then, of course, there is the among other things, which, because that can be literally anything. And the authors do acknowledge that there are also many other definitions of intelligence, of course, that focus on different topics from goal achievement to skill acquisition, to human level ability, but of course, all of these definitions have their strengths and weaknesses. Each one captures some aspects and other aspects it does not. But now let me pose a question to you, anyone watching this. Do we really need or even want a definition for AGI? And I pose this to all of you because I don't think I have a great answer myself. My initial thoughts are that maybe it's not worth trying to define the term because there are lots of different definitions that would make sense. But I don't think any will encapsulate everything that anyone wants. Everyone has different ideas when they think of AGI, and maybe that's not such a bad thing. Perhaps the more fruitful path is to just not really worry about that and instead focus on being precise about what you want to build. For example, I want to build a stateful agent that can learn things over the long term and that can plan about the future. GPT-4 cannot do that. But does that mean I should dismiss it or that it's not AGI? No, obviously, I mean, who cares? I know what I want to build, and at least to me, I think that's what's important. Sorry for the tangent there, and to get back to the point, is the use of the word AGI here, including in the title, appropriate? Honestly, as long as it gets the point across, because at the end of the day, we are science communicators, who cares? I don't think there's any reason to hide from the term like it's the boogeyman like lots of people have. And in this case, it does indicate the discussion on the larger topic as a whole. So yeah, that's my thought. Who cares? Sorry it's not as spicy as some of you might have hoped. Overall, this was a really fun read and a great work by the authors. If you've enjoyed this, consider subscribing or even follow me on Twitter for some maybe a bit hotter takes than this. But thank you so much for watching, and I hope to catch you all next time.